Okay, go ahead.
Okay.
Yep.
So, good morning, everyone. Again, I'm presenting today about antimatter. I want to ask first, who has like any information about this subject?
Google.
Yeah.
Other than Google?
Antimatter?
Yeah.
It's Google?
Okay.
he asked
Clearly no one knows what
Yeah.
it. So,
who has the information.
I have no
about
idea.
Google.
Yeah, either.
Dark matter. Like
I want to start first about some basic concepts of our universe. What is our universe consist of? Like the main units. The main units cannot be divided in the universe. What is it?
atoms?
It is the atoms.
Yeah.
And what is atom consist of? Is consist of
Nucleus?
nucleus, yes, nucleus, and electrons circling around it in some orbits. We know that electrons has negative charge, and the
Proton.
nucleus consists of protons and neutrons. And neutrons, it's like equal, no charge, and protons, it's positive. So, the antimatter, it is exactly the same concept, but has how I can say, like positive charge electrons, and it's called positron, and the protons are negative. So exactly the opposite of atom. This is scientifically exists in universe, but so I hope now you understand what is the concept of antimatter.
No.
Mhm.
Can you do it
it's
again?
So positive.
No, can you just say it again?
Like this chair, what is
Yeah.
consist of?
Atom.
Atoms with negative electrons and positive protons. So the anti, like, can I say anti-chair? It's the same substance, but the opposite in charge.
Ah.
You see,
So the protons.
in some place in universe there is anti-me.
So there's another chair, but we can't see it.
Yeah. So
There's
it
another,
just
another Omar we can see.
We can't.
and not we maybe
Yes.
we will I
Yes.
will find it someday. But I hope you understand what is like. We thought that in universe there is energy, light, and matter. Only that.
Yeah.
There is also antimatter. You see? So should I move on now?
Yeah.
Yeah.
Okay. So as you see,
Better.
Oh, skip, just cancel that.
Ask
Just,
me.
yeah,
Update
yeah,
it.
okay, there. Thank you.
okay. Should I explain? Yeah.
Do you know about antimatter?
Yeah.
Okay.
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 Like for example, anti-hydrogen consists of a positron, which is positively charged electron.
Okay.
Okay, called positron. And yeah, and antiproton. Antiproton is negative charge. So you see, the hydrogen we know it consists of no neutrons and one proton, one electron. So exactly the same, but the opposite in charge. Okay. So when was this antimatter created? It was created. You know the Big Bang theory.
Yeah.
No, I mean I heard of it.
Yeah, it's like in general the whole universe, the whole matter was just one spot,
Atom.
smaller than atom,
Smaller.
smaller than atom. The whole universe, everything we see, everything we discover, was like that. But like unimaginable
Explosion.
weight.
Oh,
Yeah.
caused the explosion?
Yeah, and with pressure and heat, it's caused the explosion.
Uh-huh.
After very, very few fraction of seconds, maybe 0.1 billion of second, the antimatter was created. So after that, I will start this video so maybe you can understand well. I couldn't explain, so you can understand why antimatter now is lost, and why 99% of our universe for the present time consists of only matter, and 1% maybe of antimatter. Where does that antimatter go?
Oh, can you get the volume? No, but it's over there on the wall. Thank you. Thanks, Reem. Thank
Okay.
you.
For the tiniest increment of time that is possible to talk about, 10 to the minus 43 seconds. The temperature was 10 to 32 degrees, and the density downright indescribable. At that instant, there was only one universal force and one type of elementary particle. But it wouldn't last. At the end of this instant, gravity separates itself from the union. At 10 to the minus 35 seconds, the strong nuclear force exits the union as well, and this triggers inflation, the event where the universe instantaneously grew into size, from tinier than an atom to an unknown large size. This expansion and subsequent cooling down to 10 to 27 degrees allows 6 different types of quarks to form. At 10 to minus 12 seconds and 10 to 15 degrees, the weak force and electromagnetism separate, and we have the 4 independent forces we know today. At this point, all 6 types of leptons have formed, including the electron. At 10 to the minus 6 seconds, up and down quarks have formed protons and neutrons. All heavy quarks have decayed. All heavy leptons have decayed. All antimatter has disappeared. And by the time the universe is only 1 second old, protons and neutrons are already getting together to form the lightest atomic nuclei.
So I hope you understood this video, that the antimatter was lost before this 1 second complete. In the present days, like not right now, in the past 30 years, there was industrial production of antimatter was located in CERN. This is like European Organization of Nuclear Research. It's 1990. It was 1995. This project, I can explain. It's like a track, very very long track, with 27 kilometers. They put inside this this track 1 atom. They could only do that with hydrogen atom. 1 atom of hydrogen, and the other side another atom, and they make it like go with the speed of light. So when they hit each other, the antimatter will create it. This is the mechanism of how the industrial production of antimatter. It was they produced at 1995 only 10 atoms, and this is 1/1 billion of gram, and didn't stay along. Just one 0.1 of thousand second only, and immediately disappeared.
Where they
You
It
mean
just
the collider?
turned to energy. This matter turned to energy. So yeah, this is the mechanism how they produce the antimatter. And we know this is who from you knows this.
I remember this.
Einstein.
Energy
Yeah.
equal
Mass.
weight,
Mass.
mass, yeah.
And the speed of light,
Yeah.
force of two.
Right.
So what was Einstein say that energy equal to mass and mass equal to energy with some specific conditions. Okay. This video actually will explain better than the previous one how great is the antimatter can produce of energy. You can see that.